Hi everyone, I am going to teach module number 4, moment of inertia. So now we are going to see about the introductory part in the moment of inertia. So moment of inertia is said as the second moment of area. Guys, we already knew that moment of area means moment into area. So now in the moment of inertia, we are going to see about moment into area moment into distance square. Right? So as I said, the moment of inertia is defined as a quantity expressed by the body resisting angular acceleration. So this is the product of the sum of the mass of every particle into square of the distance from between them. Okay, or very simply you want to say means it's an amount of torque needed for a specific angular acceleration in a rotational axis. The moment of area is also known as angular mass or rotational inertia or second moment of area. Okay, so moment of area means area into distance, but second moment of area or a moment of inertia means a moment of area into distance square or area into distance square. Okay, so it is usually specified with respect to the chosen axis of the rotation, and it mainly depends on the distribution of mass around an axis. Okay, moment of inertia varies depending upon the axis that is chosen. So the unit of moment of inertia is mm/4. Okay, guys. So now we are going to see about moment of inertia in detail in the forthcoming presentation. So, in the moment of inertia, very important topic that is to be known before doing the moment of inertia is radius of gyration. So, you consider any plane figure and with a distance of k from the reference axis. Okay, always in a moment of inertia, you have to consider a reference axis. Okay, reference x-axis and reference y-axis, whatever may be the an object. Okay, that object should be kept in with respect to some reference object, and it should have a centroidal x-x axis and centroidal y-y axis. Okay, so in the radius of gyration, the moment of inertia of the body about an axis is sometimes represented using the radius of gyration. So now we can define the radius of gyration as an imaginary distance from the centroid at which the cross section is imagined to be focused at the point in order to be chosen in order to be obtained in the same moment of inertia, and it's denoted by the term called k. Okay, so k is equal to root of I by a. Okay, so how to be actually you can ask me how directly we are getting k is equal to root of I by a, right? So actually guys, moment of inertia is always denoted by the term I. Okay, so I is equal to a into k square. Okay, k is the imaginary distance and a is the area. Okay, with respect to ix you will get I is equal to a into k square. So you want only k square at one side means it will become k square equal to I by a. Okay, if you want to transfer the square, then k will become root of I by a. Likewise, for y axis and for z axis, you have to make. Okay, so ky is root of I y by a, and kz is root of I oz or joz by a. Okay. The unit of radius of gyration is, see guys, the unit of in a moment of inertia is mm/4, and for area it's mm/square. Okay, so finally you will get the distance as mm, radius of gyration distance as unit as mm. Okay, so now these are all the varying three formulas for radius of gyration. So here for the moment of inertia, Ix is equal to a into x square or a into y square. Likewise, you can take up. Okay. So now I'm going to teach about a very important theorem called the perpendicular axis theorem in the moment of inertia. See guys, moment of inertia for a two-dimensional object about n axis passing perpendicularly is equal to the sum of moment of inertia of the object about two mutually perpendicular axes lying in the plane of the object. See guys, in the polar moment of inertia, see if you have all three axes, you will get r square is equal to x square plus y square. Likewise, we are going to prove it. See guys, so here as I told you, right, r square is equal to x square plus y square. That is with respect to this three axis, three-dimensional axis. One axis is x, one axis is y, one axis is z. Right. So assume a small elementary strip dA. Okay. So in that, see guys, r square is equal to x square plus y square. Now in the perpendicular axis theorem, you have to prove that when about two mutually perpendicular direction, when is equal to the sum of the object about two mutually perpendicular axes lying in the plane of the object. That is Izz is equal to Ixx plus Iyy. Okay, we shall see the proof of the perpendicular axis theorem. Okay, let us assume that there are three mutually perpendicular axes named x, y and z. Okay, they are meeting at O. Now you consider the object lies in the xy plane having a small area dA. Okay, it is having a y distance from x-axis and x distance from y-axis and r distance from z-axis. Okay, so Izz, Ixx and Iyy be moments of inertia about x, y and z-axis respectively. Okay, we know the formula for moment of inertia, that integration of r square into dA. Also, we knew that r square is equal to x square plus y square. So just put the value in the above equation. So you will get Izz is equal to integration of x square plus y square into dA. Okay, so x square into dA plus y square into dA, you will get two things. So we knew that integration of x square dA is Ixx, integration of y square dA is Iyy. So you will get Ixx is equal to Ixx plus Iyy. So this is how you need to prove the theorem, guys. So these are all the different like a very important theorem you have to be known in the moment of inertia. So I'll continue about the next derivations in the moment of inertia in the upcoming presentation, guys. So thank you everyone for watching. Thank you all.